Alright, hello. This is the second part of my video. Before watching this, you should probably watch the first one, of course. So here is my code. We're going to do some data input and validation. So for task 1, I have my variable name equals input. What is the name of the company? How many weeks per year does it operate? And it's going to be 2 values. So say 1 space 2. And here I'm going to check the size. And here I have my while loop. So while R is not equal to 1 and C is not equal to 2, or the second value of the row matrix is less than 1 or it's greater than 51, then my while loop will continue. It means, so it will output a warning saying you did not correctly input the time and or weeks. And your name, it will make you input the name again until you get it right. So the only way you can break the while loop is if you don't follow the stuff up here. By the way, I'll run my code at the end so y'all can see it. I'm just trying to explain the code for now. Here for y'all. So for task 2, pname equals input. Please input the names of the products of the cell array. This, I just basically just input the names in a matrix. So this isn't going to be numbers, it's going to be strings. So you have to put it in curly brackets. And here I check the size. If length of p name is less than 1, then it's going to be an error because obviously you didn't input anything, so my code wouldn't run. And else if row is greater than column, we have another issue because this needs to be a 1 by 2 matrix. So the row is always going to be less than the column. So here we have afam equals pname prime. That's because I need to transpose it. It will make more sense later because it's important that you have it transposed. So here for task 3, for task 3, we have mname equals input. Please input the machine name cell array. RC equals size of mname. While R is equal to 0 or C is equal to 0, you do not provide any data because, again, if you don't have in a row or a column, you didn't input anything. So for mname, mname, you would have to input it again. So the correct issue. If you don't correct this, then you're going to stay in a while loop for an infinite amount of times. I'm just saying you all would know that right now. So while R is greater than 1, we'll output the warning. The data you entered is not a horizontal array because, again, this thing must have only 1 row. And then again, they're going to ask you to put the machine name again. And you're going to check the size each time. So in task 4, we're going to make a for loop for f equals 1 length of mname. And for that, you're going to have mnum equals sprintf. How many hours per week is available? Sprintf allows us to store it. And then here mnum, we input it, lets us input to what we've stored. And here we have y machine equals mnum times 52. Mnum times 52 is the machines in the amount of machines in the year. And here at sprintf, the yearly machine availability for %s is that. So again, more of this will make more sense when I run the code. So here we have more for loops. For Toby equals 1 length of afam. And remember that afam is the product names. So here I'm going to calculate the length because the for loop is based off of how many products you have. And here on our below that we have for then equals 1 length of machine names. So we have a little nested for loop. And depending on how many machines you have, the for loop will run. But remember, the innermost for loop is the one that will end first. So we're going to go through that one before we go through the Toby for loop. So here, v equals sprintf. For sprintf, how many machine hours for %s to %s require. And then we have mname then and afam Toby. And v equals input v. We're going to input whatever we had at v equals sprintf. And the d equals d. The d is basically letting us so that the values that we have in v don't erase, so we can input a matrix that we'll be using for later. And here we have we're going to end it. And now for here we have multiple sprintfs, so we can do the same exact thing that we did before. But we don't need to put this into for loops because we're not going to be using it multiple times. We're just using it for later calculations. So W equals S per F, you can see here. Please input the material cost. And again, you just re-input W equals input G, G equals GW. So we cannot erase our values before. We can keep on going. The same for X equals S per F. Please input the labor cost and X equals, and input X, same thing. H equals HX. You don't erase anything. You keep on storing the next value. It allows our code to be flexible. Y equals S per F. Please input the selling price for % in S in dollars. And then Y equals input Y, E equals E space Y, allows us to not erase what we had before. And same with the Z. And here, or my Y demand equals A times 12. This allows me to put the yearly demands, but this time it will be in a matrix, since my A is in a matrix. That's why I have my A equals matrix A space Z, so it doesn't erase what was before, so I can do all my calculations at once. And here, CM equals Y minus W plus X times Y demand Toby. That is my contribution margin. So it basically, my Y is my Y is my selling price, and my W and X is my different costs. So we're going to multiply that Y demand, which is my yearly demand. And the Toby allows it to be based off the for loop that we're running. And then we F print F, the contribution margin. And here we have B equals BCM because I want to store different contribution margins based off of what I had on my for loop of Toby. So let's go down. If Y demand is greater than 0, the conversions are complete, because if it was less than 0, that means you didn't really have any conversions. So I'm making sure that my user knows that I've made the conversions. So here we have data equals, so here we have a data and combine it into a matrix. So if B1 is greater than B2, then we're going to F print F this. If B2 is greater than 1, then we're going to F print F this. And remember, B is the values that I got from my contribution margin. So depending on which contribution margin is higher, is the one that will F print F. So here, I had to be honest, Charlotte has a hard code because we couldn't really make our code flexible like that. I apologize. But for D1, actually, excuse me, let me tell you what D is first before I get to it. Remember, D is my machine hours, and here I split them apart and then combine the data. Basically, that makes my traditional matrix. But here on my total data, I have since some of them are strings and some of them are numbers, I had to use this little function to be able to put them together. Here's my final traditional matrix, and that's only where I output my contribution margin and price. So let's run my code real quick. Give me 1 second so I can figure it out. So here I have Hoover Company. And then I have blankets. Then I have machine 1. And 40. Oh, here's my yearly machine availability. I calculate that every time I give in how many hours per week something is. 2, 1, 30, 20, 70, 70, 0.5, 0.25, 5, 9, 25, and 120. You see now, if print the conversions are complete using the traditional method, blankets demand should be fulfilled first. The overall contribution margin for that product is $60,800. I would have done more for my code, but we didn't have a chance to solve some of the errors at the end, so I couldn't complete it. I apologize for that. But yeah, that's my code. This may not make sense to some people as much, but I suggest y'all read the industrial engineering application. It'll make more sense, and y'all can solve it by hand in case y'all want to know the formulas and stuff. But it's also provided within the paper. Thank you for watching.